Hello and welcome to Sudoku. Here is an equation Sudoku puzzle that was created by Indian constructor Akash Dulani for the Indian Sudoku Championship of 2021. This was featured on round 2 and it was the highest pointer in the round. So the special rule of this Sudoku puzzle is, apart from the standard rules, that you have operations here and you must put digits here so that the equality sign be satisfied. So this is a multiplication, this is exponentiation, that is, this number to the power of this number should yield this result. And what you need to know about this kind of puzzle is that those operations are very restricted. The exponentiation can only be 2 to the power 3 equals 8, or 3 to the power 2 equals 9. You can try any other operation of this sort, and you will find that it's impossible. And likewise, for multiplications, it can only be 2 times 3 equals 6, or 3 times 2 equals 6, or 2 times 4 equals 8, or 4 times 2 equals 8. Those are the only possibilities. So we know right from the start that this is 6 or 8. And for the same reason, this division can only be 8 divided by 2 or 4, giving 4 or 2 accordingly, or 6 divided by 2 or 4. That's the same. But you can see 6 divided by 2 or 3 yielding 3 or 2. But you can see that there's a 2 here, so there can't be a 2 here. So 2 has to go there. And 2 has to go there. And accordingly we get those digits. And at this point we have 2 paths, 2 scenarios for those digits. But then this is a 2-3 pair, so this can't ever be a 3, so that's a 4, that's an 8, that's a 6, and that's a 3. And this is either 2 times 3 or 3 times 2 to the power 3 or 3 to the power 2, but if I put a 3 here, I will need a 2 here, and it will clash with this one. So this is 2 to the power 3, which makes this an 8. Now here, this has to be a 3 or a 4, yielding a 6 or an 8. But then the other digit 6 or 8 must go here as the result of this multiplication. And the other one, well, I'm not sure. There has to be a 2, but there's a 2 in this multiplication, so the 2 must be here, together with 4 or 3. And we get the 2 of this multiplication must be here with a 3 or a 4, and the result is 6 or 8. So all this beginning is somewhat forced. Now you may wonder on this row where 9 goes, because 9 is a big digit. And 9 can only be the result of a sum or the highest digit in a subtraction. So here 9 can only go here. We know that 8 and 6 are there. And where goes 7? Where does 7 go? Well, 7 here would need another 2. So 7 has to appear here, which means that 7 is subtracted from this digit or is the result of a subtraction from this digit. So this can only be an 8. And we get the answer for the other digits. So the subtraction is 8 minus 7 equals 1, or 8 minus 1 equals 7. And now the sum here is 4 plus 5. And there's already a 4 in column 2. So this is a neat start. Where should we have a look now? Well, probably here. The remaining digits are 1, 4, 7, 8, and 9. And we know that here, one of them must be the sum of the other two. So the only way, you can't have 4 plus something be any other digit here. The only possible difference is, well, let's say 9 minus 1. 9 minus 1 is 8, or 9 minus 8 is 1, or 8 minus 7 is 1, or 8 minus 1 is 7. But 8 is not available here. So this has to be a 9, as 9 minus 1 equals 8, because 8 won't go there. 7 is not here, so 7 goes there. And we get a 4 to complete the row. By Sudoku, oh no, sorry, not by Sudoku. We need here 1, 4, and 6. There's a 4 here. Here we need 1, 5, 7, and 9. There's a 1 here, there's a 9 here. So this is 5 or 7, 1, 5 or 7, 5, 7, 9, and all 4 digits are still candidates here. So I don't think it's useful to pencil mark them. Let's look for more. Here I still need 1, 3, 7, 8. There's a 7 here. So this is 1, 3, or 8. 1 or 7 here, because of 3 and 8. And I don't see anything else. Oh, here there's something interesting. 8 and 9. If this was a 7, then the total here would be 8 or 9, but they are not available. So this has to be a 1. And we know that those 2 digits are consecutive. So what are the options? This could be a 2, with this being a 3. Except that 3 here would need those to be 1 and 2, and that's not possible. So that's not a 2. And that's not a 2, and by Sudoku we get a 2 in this position. The next option is 3, with this a 4, and 4 would be 1 plus 3. That's worse. So 3 is an option here. Is 5 an option? 5 would make this a 6, and we could have 1 and 5. That's also an option. And then the next option would be 7, but then this would be an 8 or 8. So the only 2 options are 3 and 5, making this 4 or 6. And this is a 4-6 pair. That's interesting. And so this is 1 or 3, or 1 plus 1 and 3 and 1 and 5. And we see here that the missing digit has to go into this cell, and this is a 1. So that's not a 1, that's a 1. And that is some progress. 6 is not here. Because of the pair, 6 is not here, so 6 goes there. And this resolves the 4s and the 6s, and we know that this was, in the end, 3 plus 1 equals 4. These 2 digits now must be 5 and 9. 9 is not here. So this is 5, this is 9. This column needs a 9. This column needs 2 and 7. And we need 5 and 6. I said 7 and wrote down a 5. I think my writing is ahead of my thinking. Where should we look next? Probably here, because 5 or 6 is the difference here, so this has to be a big digit. It could be a 6 with a 1 and a 5. It could be a 7 with a 1 or 2. No, 7 and 2 wouldn't work because of this, but it could be 7, 1, and 6. So the options, we have 6 minus 1 equals 5. We could have 7 minus 1 equals 6, but not 7 minus 2 equals 5 because of this. Or it could be a 9 with 3 or 4 here. Let's say 9 minus 3 equals 6, or 9 minus 4 equals 5. So not a lot of restrictions here. But this is definitely 6, 7, or 9. 1, 3, or 4 here. This 3 says that this can't be a 3, it has to be 1, 3, or 7. I still need a 2 in this column. It's not here, so it's here. I get this 7 and this 2. And there's another subtraction. But I'm seeing 8s here, so this is an 8. Let's do some Sudoku. That's what we are here for, after all. 2, 2, so this is a 2. I still need the 3 here. It can only go here. And 5, 7, or 9 here. This column needs 5, 6, 7, and 9. Oh, this can only be a 9. And this row now needs a 9 in this position. These now are 1 and 5. There's a 5 here. So this puts limitations on those digits. We now get a 1, 5, 7 triple, sorry. So this can't be a 1. And that's interesting because now the sum can only be a 9 here. Within 1, 6, and 7 here, there are limitations. And with this triple, the remaining 3 digits must be 3, 4, and 8. And because of those digits, this has to be an 8. By Sudoku, we get this 3, this 8, this 4, and the difference is 5. So we get this 6, this 1, this 6. We get a 1 here. And that is some good progress. Here, this row now, well, is it the right place to look? I think this row needs 5, 7, and 9. So there are limitations. This row now needs 3, 4, and 5. There's a 3 and a 5 here. And this row now needs, let's have a look. It needs 1, 3, 6, and 7. So the difference can only be 7 minus, well, 3 has to go here, and 6 and 1 there. And that should resolve, it should disambiguate a lot of stuff. That's a 5, that's a 7, that's 5. And we can now find the remaining digits here and a 7 there, and it all seems to work. So that was very well put together, as usual, with puzzles by Akash Dulani. And in my opinion, it's probably not as hard as the total of points suggests. Well, to be honest, when I took part as an international contestant in this tournament, I broke this puzzle 3 times. And when I came back to it afterwards, well, I didn't break it because I guess with less pressure, a little less pressure, sorry, it goes better. But whatever. It was a fun experience nonetheless. Thanks for watching this video and see you soon on Sudoku Championship.